In this video, we'll go over the scientific notation and conversions. Now let's go ahead and start with scientific notation, and what it really is just a shorthand way of writing very long numbers. A lot of the times, these numbers might be very inconvenient to type into a calculator, or they're so long that you might miss something, so it introduces a lot of error. So using the scientific notation really saves you a lot of trouble and saves you a lot of that error as long as you know how to use it correctly. So technical definition is that we use the scientific notation to represent numbers that are either very large or very small, and they might look very long. So an example of this might be this measurement we have, this count of atoms, we have 1,020,000,000 atoms. So again, if you had to do calculations with this and you had to retype it every time into the calculator, it'd be very inconvenient and you might miss some zeros every time that you type it in. So in order to solve that, we can use scientific notation, which is a shorthand way of writing this, and it would look something like 1.02 times 10 to the ninth power number of atoms. And so we can also use this for very long decimal numbers too. And so the way that decimal numbers would work is that we have here 0.000000235 meters. It's a very accurate, very specific measurement that we have, and we don't want to lose any of that accuracy. So by using the scientific notation, we can shorten that down to 2.35 times 10 to the negative 6 power meters. So now let's look at the format, and so we know how to work with scientific notations and how to change numbers into scientific notation and out of scientific notation too. So it's the format that it will follow. And so notice that here we have a left section and a right section on either side of this multiplication symbol. So now in this left section, this is called the coefficient. The coefficient has to be a number between 1 and 10, so it has to be greater than 1.0 and it has to be less than 9.9. The reason for this is that the decimal in scientific notation is always placed after the first digit. So you can see it on this example too, 1.2. And so now, for when we're using scientific notation, make sure that you show the correct number of significant figures. We talked about those in the last video. Now, for the right section, this is called the exponent. And what the exponent does is it represents the scale of the value, or in other words, more practical terms anyway, is that it tells you the number of spaces that you need to move your decimal. All right, so let's look. Never mind. Now, when you have a positive exponent, you will shift your decimal to the right side. And when you have a negative exponent, you will shift your decimal to the left side. But let's look at these examples a little more closely so we can make a little more sense of that. All right, so if we take this first example, 1.02 times 10 to the ninth power number of atoms. If we were to take this out of scientific notation and into the standard format, you would get this number. Again, 1,020,000,000 atoms. And so to go from this to that, well, all you have to do is keep in mind where your decimal place started. So this one, we have the decimal place here between the 1 and the 0. And this next number, we have it right here at the end. It's an implied decimal. So now to go between that, notice that your exponent is to the positive ninth power. So now we're just going to take that same starting place of our decimal and we're going to shift it over 9 places to the right. So if you'll, all right, so again, we started on here between the 1 and 0 and we shift over 1, 2, 3, 4, 5, 6, 7, 8, and 9 places to take it in to this end. And so all those places that you shift over, you just fill in with zeros until you get to that final resting place for the decimal. Notice that both of these numbers will still have the same number of significant figures. So here we start with 3 significant figures, and this final number, we still only have 3 significant figures. All these zeros, they're just placeholders, and we don't really need them according to our significant figures rules. For this, keep in mind that when you have a positive exponent, you will always be expanding your value and that you're always making it a very large number. So in this, we started with 1.02 And that's a pretty small number. There's nothing too great about it. But when you compare it over to the full value of it, this is in the range of billions. So again, because we had a positive exponent, we have a very large value in the billions. Now, how does that compare to the negative exponents that we might have? Well, it just says that we'll be shifting our decimal in the opposite direction over to the left. So if you see this number outside of the scientific notation, you see that we started with the decimal between the 2 and the 3. So here are between the 2 and the 3, and we'll shift it over to the left by 6 places. So if you count this out, let's see, we'll have 1, 2, 3, and 4, 5, 6 to bring that decimal to its final resting place. So now we have that number outside of scientific notation, and it is 0.000000235. And again, notice that we didn't lose any significant figures and we didn't gain any of them either. We still have just 3 significant figures in both of these values. They just look slightly different. And so keep in mind for this one that the negative exponents will give you these very small decimal numbers. All right, and so scientific notation is very useful for eliminating a lot of errors that we may have whenever you're putting these numbers into a calculator. So go ahead and watch this video for a very good tutorial on how to use the scientific notation in our class calculators. So just a heads up is that I know that a lot of you use your phones for calculators, and so scientific notation is just a little bit more difficult to use on your cell phones. So for this reason, I highly recommend that you grab one of our class calculators. All right, so now we move on to dimensional analysis, and this is really just a skill and a technique that we can use for converting between different units to fit our problem. So let's look at that a little bit more closely. So it's just a problem-solving strategy that will convert units using a conversion factor. Now, the conversion factors will change the units of a measurement without changing the value. All right, so what does that mean? So let's go ahead and look at this. So, if I gave you 12 cookies, well, another way of saying that same amount of cookies, you could just call it a dozen cookies. That doesn't change the number of cookies that you have. It only changes the name that you give to those cookies. So again, it goes along with the idea that 12 cookies is the same as 1 dozen. And then you're familiar with this one too, that 1 yard is the same as 3 feet. Again, exactly the same length, just different names and different numbers that we use for that same measurement, that same amount. All right, the way that we can set up our conversion factors is that we can set them up as a proportion that we can use mathematically. So in this one, with 12 cookies, you can set it over 1 dozen, and you know that they're still exactly the same, or you can do the opposite of that and set 1 dozen over 12 cookies. Again, these two are opposite, but they're still worth the same. Same thing for our yards and feet example. You can set 1 yard over 3 feet, or you can set 3 feet over 1 yard. And so this is the format that we'll be using for our conversion factors, so we can easily use them in our calculations. All right, so let's go ahead and hit the ground running and use this example with our dimensional analysis. All right, so say that you have this, you had 300 cookies and you want to break this up into dozen packages. All right, so for this, you'll need to know your conversion factor that, again, 1 dozen is the same as 12 cookies. And you can set up your conversion factor in 2 ways, again, with cookies on top or cookies on bottom. All right, and so the way that this dimensional analysis works is that you always want to take your starting information. So in this case, we have 300 cookies. So we'll go ahead and copy that down, 300 cookies, and we'll set up a table around this. So this isn't just a regular cross. There's actually very special meaning to each of these sections. So let's talk about those. So now to set up a dimensional analysis problem, you're taking your starting information and setting it up in that top left box. That's always the way you started. And then in the next section, this is where you set up your conversion factor. All right, but let's see, you only have space for one conversion factor, but you have two ways of writing it. So how do you know which one is right? Well, the way that you do it is that you're going to take the unit that you have starting in the top left, and you will just shift that over to the bottom right of the next section. All right, so notice here that I'm taking my cookies on the top left, shifting it over to the top right, and then I will match this to the two conversion factors I already have set up. So let's say I want cookies on the bottom. This has dozen. That doesn't work for me. This on the right does have cookies on the bottom. So that's the one that I want. So we'll just take this conversion factor and copy it exactly as it is onto my table. So again, I have 12 cookies on the bottom and I have 1 dozen set up on the left. And this takes care of this first step of dimension analysis. Just set up this table in a way that your units will cancel out. Step number 2 is to cancel the matching units. So if you look on this, we have 3 units written on this table. We have cookies, we have dozen, and we have cookies again. You want to cancel out the matching ones if they are set on top and bottom. So these cookies will cancel out, and dozen doesn't have anything to match with, so it's just left alone. And finally, all that's left is to calculate. Well, calculate what? All right, so on this table, we have 2 math calculations that we can carry out. And so when numbers and units are set up across this bar on the same side, either top or bottom, then they are multiplied together. And then when we have values on top and to the bottom, those will be divided. All right, so if you just take everything that you have left over and you ignore everything you've canceled and rewrite that, we get this new math operation where we have 300 times 1 dozen divided by 12. All right, so if you just carry out this calculation, put into your calculator, 300 times 1 divided by 12 will give you the result of 25. And then the last unit we have left here is dozen. All right, so it's something very important to go over because I can already tell that a lot of you are going to just take the shortest way out. You're going to set up your table, you add in your numbers, and you're going to ignore the units completely. And so I'm here to tell you, don't do that. You should always write in the units because that is the whole point of dimension analysis, is changing the units that we use, not changing the values of our numbers, only changing the units that we use. And so if you're not writing in the units, then the numbers don't even matter. When you do this correctly, the dimension analysis table should introduce a new unit and it cancels out the starting unit. So we saw that in that last example where our cookies and cookies were matching, so they canceled out, and now our new unit became dozens. Now, when you do this and you can visually see that the units you have written cancel out, you are almost guaranteed to be correct. The only thing that could give you the wrong answer in this is if you don't put it into the calculator correctly. All right, now in this last section, let's go ahead and get into the unit conversions. So the whole point of that dimension analysis was to change out units and change the names that we were using. Well, if you remember back to the metric system, or more specifically the SI system, when we talked about the different types of units that we can have, you remember that we can have different ranges and different scales for our different prefixes. So again, we can have giga, mega, kilo, hecto, deca, our base, deci, centi, milli, and micro. And these all have a different value that is associated with it. So now we can use that skill of dimension analysis that we just learned to convert between these units, and it will make it a lot easier to keep track of what's changing to what and what your new values are. All right, so now we can use this SI prefixes table. Make sure that you save it somewhere that you can see it again, because we can use this to set up our conversion factors. So just a short little example on this is that if you have something that is asking for a kilometer, here you look for the prefix kilo, symbol K, you know that it represents 1,000. It represents 1,000 units of your base. So to set up the conversion factor, you just said 1 kilometer is equal to 1,000 meters, 1,000 units of your base. All right, this next one, if we're looking at centimeters, here we have centi, here's the symbol C, and so that represents 0.01 of the base unit. So you just write that as your conversion factor. This time, 0.01 meter is equal to 1 centimeter. And then finally, if we have 1 hectogram, this would represent, let's see, 100 grams. So you just write that in as your conversion factor. And so you can use these conversion factors for changing the names and the ranges of your units. All right, so let's go ahead and do an example and see what that would look like. So we have a problem here. We want to know how many milliliters there are in 12.09 hectoliters. So for this, you would need the conversion factor of 1 hectoliter. So here we have hecto, symbol H, we know represents 100 of the base, in this case 100 liters. And now we also want to know what milliliters are. So you'll go back to your table, find milli on this, symbol M, that represents 0.001 of your base. So we know that 1 milliliter is equal to 0.001 liter. So now we have 2 conversion factors that we need to use. So let's go ahead and set up our dimensional analysis table so we can cancel out these units and know what we're doing. So again, start off with your starting information in the top left of your table. Next step is that you will take your starting unit, forget the number, just focus on the unit, and you will shift this over to the bottom right. All right, so now once you have the bottom right, you want to head back to your conversion factor and set it up in a way where you have hectoliters in the bottom. So in this case, we'll set 1 HL on the bottom is equal to 100 liters on the top. Step number 2 is to just cancel out the matching units. So you have hectoliter and hectoliter. These two will cancel out, and you will have liter left by itself on the top. Now, once you have set this up, all you have to do is calculate and put your numbers together. So if you just copy this over into a math operation, we get that 12.09 multiplied by 100 liters is divided by 1. If you put this into a calculator, the result that you get is 1,209 liters. Now, notice that your final unit in this is liters. Now, the question being asked is how many milliliters. So we're still not quite done with this. We still need to go through one more step where we take our liters and convert this over to milliliters. So now let's go ahead and take the same result that we just got and set it up in a new table. In this case, 1,209 liters is our starting point. And same thing, you'll take this unit, shift it over to the bottom right, and use your new conversion factor to set it up in a way that you have one of these on the bottom and the other one on the top. So in this case, we can set liters on the bottom, so 0.01 liters is equal to 1 milliliter on the top. All right, again, look for your matching units, liters and liters will cancel out, and we're left over with just the milliliters unit. If you copy this over and you set up your math operation, we get 1,209 times 1 milliliter is divided by 0.001. Go ahead and put this into your calculator, and the result that you should get out of this is 1,209,000 milliliters. So this will be your final answer of how many milliliters there are in 12.09 hectoliters. All right, and now I want to just point out one more thing to you, because notice that in these problems that we just went through, we went through 2 steps, 2 conversions that we made on this. So notice that we ended this first conversion in liters, and the next one we started with liters. So now, really the beauty of this whole dimensional analysis and what could make this a lot easier for you down the road is that you can combine different conversions into a single calculation. So let's go ahead and look at what this problem would look like if you wanted to do it all in a single step. So again, we take our starting amount from the problem, 12.09 hectoliters. You want to take your unit of hectoliters and shift it over to the bottom right, and then fill in with your conversion factor, with hectoliters being set on the bottom and its equivalent being set on the top, 100 liters. So again, if you cancel out your units, you'll see that hectoliters will cancel out and you're left with liters. Well, you still have another conversion factor you can use that has the unit liters. And so instead of making your calculations at this point, we can just go one further. We can extend our table one more time and start over again at step number 2. So we'll just take our liters on here and shift it over to the bottom right in this case, and we'll look to our conversion factor. Make sure that you take the units, you place them in the right places, and you match the numbers that go with it. So in this case, we get 0.001 liters on the bottom and 1 milliliter set on the top. Look for the matching units, in this case liters and liters will cancel out, and we're left with milliliters, which, remember, that's what you want to answer in the final question, how many milliliters. So in this case, we've set up 2 conversions in the same table, and we've seen that 2 sets of units cancel out, but we're still only left over with 1 unit, which is the one we want for our answer. So you can take all these numbers and you copy them over. So we have the 12.09 times 100 times 1 milliliter set on the top, and these on the bottom you will set 1 multiplied by 0.01, and there's no units left here in the bottom. So you can take this information, you put it into your calculator, and you'll see that you get out the same result out of this. So the one thing to look out for that might mess up your answer is the order of operations, because as you saw in the calculator video, is that if sometimes your multiplication and division might be paired incorrectly. So if you just put this in as it is to your calculator, what you'll get is that you'll get 12.09 times 100 times 1 divided by 1, and then that whole result multiplied by 0.001. So what you want to do to make sure that you don't make this mistake is just use the parentheses that go with the calculator. So you'll take your top quantity and multiply these all together and open and close parentheses, and after that you divide it by the bottom portion that is also separated by parentheses.